Greetings and welcome to the next video in the Aviation Safety Risk Management through Hazard Analysis series. And this presentation is going to take on the topic of risk terminology. Now you might wonder why this presentation wasn't offered at the outset as video number one, as it lays the foundation in terminology that is then used in subsequent videos. The explanation is, had I shown this topic as video number one, it's unlikely that anyone would have watched video number two or any other video for that matter. It's just a dry subject and there's really no way to make it interesting. But it's important. And before we can progress much further, we'll find that we need to have a very solid understanding of exactly what some of the key terms in risk management mean. So what are those terms? Well, here's a list of some of the most important ones. By no means is this an all-inclusive list, but it's the ones we'll cover in this presentation. So let's get started. And before we jump into the actual definitions of the terms, I wanted to make a quick pitch for the idea of standardizing terms, because as we will see, some of these terms have multiple definitions in different places. And of course, most of them have sort of a common understanding, something that we would find in just the common vernacular. But the federal regulations go a long way towards standardizing these terms for use in risk management. And you can see two of the most important titles in the Code of Federal Regulations up there. And one of the things that will eventually start to become clear is that the roles and responsibilities for different organizations can be traced all the way back to these definitions. So agencies like the Federal Aviation Administration, the National Transportation Safety Board, the air carriers, they all have their roles and responsibilities. And it's important that we have this sort of common language that we can use so that when we start talking about aviation safety risk, all of the different organizations mean the same thing. So let's start with that key term, risk. This is sort of at the foundation of everything else we're doing. And risk is probably one of the most redefined terms that we'll find. If you just do a quick Google search on this term, you will no doubt find dozens of different definitions for this term. But you'll almost always find that these definitions include two common elements. There's always going to be some kind of a probability term. In this case, the word likelihood is chosen. And then there's going to be some term that is indicating the type of outcome or effect. And in this case, that word severity is pointing to that. Now, the idea of this being the potential effect of a hazard is really a shortfall. It's unfortunate that this definition includes that little prepositional phrase at the end. And so I want to show you one other definition that is not necessarily applied in aviation risk management, but it gives you a sense of where risk management in general is going as a community. And when I say community, I mean a global community. Here's the definition from the International Standards Organization. It's eloquent, it's simple, but it's incredibly powerful. The effect of uncertainty on objectives. And the reason that this definition is so powerful is if you think back to the previous presentation where we looked at the risk matrix, identified a number of shortfalls associated with only looking at negative effects and ignoring the objectives, the positive side of that spectrum. This new definition, which was adopted in 2009 and reaffirmed in 2018, was an effort by that global risk management community to open up the entire spectrum of things that can happen. I mentioned at the outset that these definitions are important in defining the roles of different organizations, and the term hazard is a very important example of that. So you can see from 14 CFR 5.5, it's defined as a condition that could foreseeably cause or contribute to an aircraft accident. You'll also find that same definition in FAA orders, but this one is particularly important to the NTSB. And the reason is that they are the organization in the United States anyway that is responsible for investigating aircraft accidents. And what they determine in part is what caused or contributed to each accident. So that's the organization that has the responsibility and, quite frankly, the authority to determine what those causal and contributing factors were. And so I'm paraphrasing in that second bullet by saying that the NTSB's role is partly to define the hazards. What are the aviation hazards? And that last bullet is a teaser for something that's coming in a future presentation. It's critically important that we know what the hazards are and specifically how many there are. And that's really important to us when we start to talk about the idea of a target level of safety and what we consider acceptable risk. You saw that term aircraft accident in the definition of a hazard, so it's important to understand what an aircraft accident is. And I've highlighted in a different color there the things that essentially unlock this term aircraft accident. So if an airplane, for lack of a better term, crashes, someone may call the NTSB and report that, and then they'll go out and investigate it. If there was a death or a serious injury, or if the aircraft received substantial damage or worse, then it qualifies as an accident, and this now falls under the NTSB's responsibility to investigate it. Now, if they go out and they find that an airplane crashed, but it didn't reach these thresholds, maybe there was only a minor injury or minor damage, if they've investigated it, they'll still write a report, but they'll label it as an incident report, and they'll say it was an aircraft incident. But in order to meet the threshold of being considered an aircraft accident, you have to have those two key terms. And then the sub-bullet there just is to point out that if you really want to dive into the regulations, you'll find that some of these other terms are defined very precisely as well. Moving on to severity. So I've quoted the federal or the FAA orders, a couple of them anyway, where it talks about a hazard's effect in terms of degree of loss or harm. And then in the bubble, this is coming from a MIL standard where they have categorized different levels of severity. The FAA does the exact same thing. Here's a snapshot from one of their orders, the 8040.4 actually. And although there's a pending update to that order as I record this video, you can see that the FAA does a pretty nice job of tying the definitions of these categories back to the definition of severity, where each one of those little sub-bullets in there is, in one way or another, it's expressing that degree of loss or harm. Now, there are some problems with these definitions, and those are largely corrected in the next update that's published. But there's one thing that's not in the FAA definitions, and you can see that in the little circle on the right, and that is the idea of a monetary value being associated with some of these effects, including death and serious injury and so on. The Department of Transportation puts out guidance on how much value should be placed on each one of those possible outcomes. But it's simply not applied in the FAA as far as a risk management tool. And it creates some limitations that, again, we'll see become visible as we look at some subjects down the road. Probability is a really important term that we have to understand. And I love the short definition there, the chance of something happening. I've also listed a couple of the axioms of probability. So any axiom is just sort of the bedrock that the probability theory is built upon. And this is not all of the axioms, but it's two of the most important. The first one being that all probabilities have to reside somewhere between 0 and 1. They can include 0 and 1, of course. And then the probability of all things must equal 1. That's just sort of a way of paraphrasing the law of total probability. And I'll kind of show you what that means here in a second. And what I've done to illustrate not only the general term probability, but to sort of give you a sense of what some of the very specific types of probability are, I've divided this simple little game where we toss a coin like the one in the picture, and the rules are simple. If you toss a head, you win the game, and if you toss tails, you just flip again. There's no way to lose this game. And here's what it looks like. So we start off with the first flip where we can either win or flip again. And because this coin, the chance of flipping heads and tails is equal, 50-50, you can see those 0.5 probabilities. And then you can see the second and the third possible flip, with the last one just showing that the game continues essentially forever. And so this is not a bad way to identify some of these types of probability. And the first one I'll start with is the idea of a conditional probability. And it's just like the name implies, it's a probability that's conditioned on something else. So in this case, the probability of winning on the second flip conditioned upon the first flip resulting in flip again is 0.5. And you'll see that is repeated over and over again, but that's a conditional probability. And you can start to see there are quite a few conditional probabilities here in this diagram. The next one to talk about is the idea of a joint probability. And all a joint probability, again, the name is pretty insightful because it's just the idea of a flip again outcome on the first flip of the coin and a win outcome on the second flip of the coin. So that combination of events has about a 25% chance of happening. And so in blue, you can see all the 4 different joint probabilities in this little diagram. The next one is tying back to one of those axioms, the idea that the probability of all things must equal 1. If this coin can only result in a head or a tail outcome, and they're equally likely, you can see 0.5 and 0.5 add up to 1. And the same is going to be true for each one of the events down the road. It's also true if you add all of the blue numbers together, all of those joint probabilities, you'll also come up with 1. And that's essentially an expression of the law of total probability, the idea that all things must equal 1. The last one is a little bit more difficult to digest, but it opens the door to a number of conversations we can have down the road, and it's the idea of cumulative probability. So what you see circled in green would allow us to answer the question, what's the probability of winning after 2 throws of the coin? So the chance of winning on the first one is 0.5, chance of winning on the second is 0.25. And so as we add those together, we'd say there's a 75% chance of winning on the first 2 throws. And you could take that another step and add the third one if you wanted to. But that's the nature of a cumulative probability. And as I said, we'll apply that as we move forward. Now, the term likelihood is often associated with and considered to be the same thing as probability, but in aviation risk management, it is something very different. It is a very specific type of probability. And so let me help to sort of build the argument here for what a likelihood is. And I'll start with another definition from the FAA. It's repeated in several publications that they put out. And you can read the definition there, but I like to explain it in terms of the little risk framework we've been using on the right. And it's the idea that a hazard could occur and that hazard has some probability H. And if it occurs, it could cause or contribute to an accident. And the conditional probability of that accident is A. And then conditioned upon the event that there's an accident, that accident could be anywhere from severity 1 through severity 5, and they have their own conditional probabilities. So if we take any possible pathway through this tree and we simply multiply those 3 conditional probabilities together, we come up with what the FAA considers a likelihood. So what I've done is I've created my own personal definition that I think is just a variation on the official definition, but I like to use this because it just makes it a little bit easier for me to digest. The joint probability of a hazard occurring, causing or contributing to an accident, taking that phrase directly from the definition of a hazard, and that accident reaching some degree of severity. All right, let's move on to the last terms. And these 2 terms work together, so I've tried to put them together on the same slide. It's the idea of exposure and expected value. Now, you first saw exposure in this playlist on the very first video where I showed that there were a number of vehicles passing through an intersection. And as we count up the number of vehicles, that wound up being our exposure. How many vehicles are exposed to that hazard of ice on the runway or on the road intersection? In aviation, here are some of the more common metrics that can be used to measure exposure. Flight hours is at the top of the list for a good reason. It's used the most frequently. And part of the reason for that is that data is generally the most available. The Bureau of Transportation and Statistics does a great job of tracking flight hours for all different types of aviation in the United States. But the others have their place as well and can be used on under different circumstances. And there are others beyond this list. Really, it doesn't matter what the metric is, so long as you're consistent with it, the theory will still work. So now let's take this idea of exposure and combine it with the idea of expected value. And what I want to start with is by pointing out that this term expected value is not necessarily intuitive. In other words, especially that word expected, because it's not always what we expect. And so to begin with, I want to show you that this is a very formally defined term in mathematics by showing you this ugly equation that probably makes no sense at the outset, and it's not intended to. It's just really to show you that there is a very robust mathematical underpinning to this theory. So to explain how this really works, I like to go back to my favorite tool, the six-sided die. And if we throw that die and we ask a question like, what's the probability of a 3? It's relatively straightforward, and we can say it's 1/6, assuming all sides are equal. The question then becomes, if I throw this six-sided die, what is the expected value in terms of the number of dots? Here's what the equation above looks like if I spell out the whole thing. So you can see we're just taking the number of dots, 1, 2, 3, 4, 5, and 6, and multiplying by the probability of that outcome. And that's essentially what that equation is telling us. And then we're adding them all together. The thing is, the expected value is 3.5. And that's not even a possible outcome. So it's certainly not what we would expect. And that's the difference. The idea between what do we expect to see versus what is a mathematical expected value, which is really more of like an average or a mean. So with that understanding, the next question becomes, okay, you've laid the groundwork for this being a mathematical relationship. What's the value of an expected value? How do we use it, and why is it important? And the reason it's so important is because a lot of the numbers we work with in aviation risk management are very small. In other words, we have a very large number of airplanes being exposed to hazards, but the accident rate can be very, very small. And so we need a way to communicate very small probabilities to people who may not have a robust background or in math or statistics or those kind of things. And this is a great tool for communicating those concepts. So a simple example would be this. If I throw that six-sided die 60 times, how would I determine the expected value? Well, it's easy in this case. I would just multiply that 1/6 probability by the 60, and I would say, over 60 throws, the expected value of a 3 would be 10. 10 out of 60. If I rolled 600 times, it would be 100 times that I'd expect to see a 3. And so that's the value of this tool, and it's how it's used in aviation risk management. But it's also very important to distinguish between these different terms. What is a probability? What is an exposure metric? And what is an expected value? As long as we keep those things straight, we won't run into any problems. That's it for this presentation. That's me at the bottom right. Hope you enjoyed it, and I hope you stay tuned for the next one.